Hey everyone, and welcome back to PrepFusion. I'm Anish, and today we'll solve the remaining questions that came on the GATE 2024 from the ECE branch. Before starting solving the control questions, I want to say one thing that I know the paper came very difficult. I know the situation, like you will feel very depressed and stuff. But the thing is that previous year the electrical paper also came very difficult. Everyone was depressed that I scored so low. How will I get that rank? Like I prepared so well, still like I'm scoring so low. What will happen to me? I will get very low rank. But the topper of that paper even got very low marks. Okay, so here also something same will happen. So don't worry. Don't just think anything that I will get very low marks or something. I will get very low rank. Just wait for all the rank predictors to come up and the few other more information to come up. I think whatever level you have been preparing, you will get that. You will deserve that. Don't worry. Okay. So if you have any other like issues or something, if you are feeling depressed, you can like text me in Telegram personally if you want to like clear that one up. Okay. So yeah, I want to like clear that one up first. So let's start with this question. So this question was like very basic only. Basically, they have given two blocks. A unity feedback system has been given. G of s is 1 by s square. G1 of s is k into s plus alpha by s plus 4. Now alpha and k both are positive. Now they are saying that one of the poles is at minus 1 plus j3. One of the poles is at minus 1 plus j3 of what? Of the root locus, like of this root locus for variation of k. Like it was a root locus question. So one of the poles lie at minus 1 1 plus j3, then alpha is basically it should have written close to poles. I don't have the exact wording here, so I'm just going with whatever memory based question I got. So yeah, let's start basically. So like this is basically a root locus problem. Simply what condition it has to satisfy. If one of the poles lie here in the root locus, then it has to satisfy the angle condition and the magnitude condition. Now which condition we'll use? We'll use the angle condition. Why? Because we don't know the value of k, we don't know the value of alpha. Now if I use the magnitude condition, then k will also come up in the magnitude term, right? But I don't know any information about k, so I will just use the angle condition through which only unknown will be alpha and I can find my alpha. So what is it basically? Basically if any point lies on the root locus, then it should be equals to like this, basically 1 plus g into g of s into g1 of s should be equals to 0. Like this is the characteristic equation. If that point s at that particular point, if it lies inside the root locus, then it should satisfy the characteristic equation. Then I will simply write g of s into g1 of s equals to minus 1. Now from here we get two conditions, like if you recall correctly from the root locus. So here I will use the angle condition. So my angle, if that particular point g1 of s at s equals to sp should be equals to minus 180 degrees and the magnitude should be equals to 1, we'll use the angle condition here. So now what should we do? So basically let's just simply write the point first. So g into g1 of s at g of s into g1 of s as s is equals to sp. Let's just write this point. So this is 1 by s square will remain outside, and s, what is s? S equals to minus 1 plus j3. Okay, so now like s is this, so this will be minus 1 plus j3 whole square. Okay, and in the numerator I have a k also, and here I have a 0, so this s plus alpha, so this will be minus 1 plus j3 plus alpha divided by s plus 4. So this is minus 1 plus j3 plus 4. Okay, so okay, I think okay, one mistake I may have made, like this will be root 3. I think this will be root 3, I think. So yeah, sorry, this won't be 3, this will be root 3. I just remembered something. So yeah, all of this will be root 3. That's why when I was initially solving this question, I was taking 3. That's why my answer wasn't matching. Forgot to change it. Okay, so yeah, this is root 3. Now this will become k upon minus 1 plus j root 3 whole square into this is alpha minus 1 plus j root 3 plus j root 3. Okay, now we are assuming alpha is like we're assuming alpha is greater than equal to 1. We're assuming this is positive. We'll see. Okay, now what is happening over here? Now this is negative, and this is positive. What does it mean? So here my which quadrant I'm lying? My x coordinate is negative and my y coordinate is positive. I'm lying in this quadrant, second quadrant. So what is the angle in this quadrant? The angle in this quadrant is 180 minus theta. So theta will be this tan inverse root 3 by 1. Okay, basically magnitude of like tan inverse magnitude of root 3 magnitude of minus 1, which is 1 itself. So yeah, this is lying in the second quadrant, this is lying in the first quadrant, this is also lying in the first quadrant. I'm assuming for now this is lying in the first quadrant. Okay, so let's equate this with the angle condition. So that is why I'm talking about angle. So this is minus 180. Now this is the denominator, so if it comes in the numerator, another minus sign will be there. So minus into 180 minus theta, which is tan inverse root 3 by 1. Okay, so yeah, this is this, and this will be twice. Why? Because we have two poles, that's why 2 times multiplication. So all these things are, we don't have to like this is very basic. So this is one thing. Now what about the 0? So 0 is basically plus tan inverse root 3 by alpha minus 1. Okay, I'm assuming this is like in the first quadrant. This is positive, this is also in the first quadrant. Now what is this? This is minus, these both of them are positive, simple tan inverse term will come, minus tan inverse root 3 by 3. Okay, which is equals to minus 180. Okay, so now simply if you multiply this minus 2 into this 180, it is 360 only. So we don't need to write it, because 360 adding 360 subtracting 360 is just full circle, so it doesn't matter. So I won't write 360 here. I will write 2 tan inverse root 3 and plus tan inverse root 3 alpha minus 1, then minus tan inverse 1 by root 3, which is equals to minus 180. Okay, now if you just equate it, what is root 3? Root 3 is tan inverse root 3 is 60, and this is 30. So 120 minus 30 is 90. Okay, so this is 90. Yeah, this is 120, and this is so this is plus 90 goes in that side, so this becomes tan inverse root 3 by alpha minus 1 is minus 270. Or if you want to add another plus 360, you can add that also, like adding and subtracting 360 doesn't matter in angles. So root 3 alpha minus 1 equals to 90 degrees. So it is plus 90 as we assume, right? It is almost in the first quadrant. So where is it? It is lying around here. What does this mean? If it lies around here, it means that I don't have a real component. My real component is 0. That means my alpha will be 1. Okay, alpha will be 1. Or you know that tan inverse infinity is 90 degrees. That's why we need to have a like finite upon 0 term, something like that, so that we get infinity. So this alpha will be equals to 1. To get it equated to 0, so alpha will be 1. So this was the answer. How other way you could have done it, that would have been a lengthy pattern. Is that now what we know is that we have been given this pole, right? And this is a third order system, and this lies in the root locus. So if you just draw the root locus, what you will observe is that, like, if you know that this is an underdamped system, like I don't know if this is an underdamped system, like if from somehow you from the question you understand this is an underdamped system, and like one pole will be dominant, and that will be two poles will be dominant and other pole will be non-dominant, that will be much left of this like origin of this plane, and 2 poles will be near this origin. Okay, so what we can write is like this. We can write the characteristic equation like this: s plus p into s square plus 2 zeta omega ns plus omega n square equals to 0. We can like equate it like this. Now from here we know that like we have been given one complex pole, obviously as the coefficients are real, my other complex pole will be conjugate of this, complex conjugate. This will be minus j root 3. And what we know, the real term is the zeta omega n. If you recall correctly from the time response chapter, this is zeta omega n and this is omega t. I don't recommend this method because this many things you have to recall. Only root locus is the best method, simple, straight. Okay, but if someone goes with this method, so from the pole we can understand zeta omega n will be 1. Okay, and omega d, which is equals to omega n 1 minus zeta square equals to root 3. Okay, from here you can find zeta, everything else you can find omega n. Okay, yeah, all these things you can find. Then you put over here and you equate this equation with this equation, 1 plus g of s into g of s, right? So you equate with this one. So basically what you will do, this will be 1 plus k into s plus 4, no, not s plus 4, sorry, s plus alpha, is it? Yeah, s plus alpha by s square into s plus 4 equals to 0. So this will be s square into s plus 4 plus ks plus alpha. Okay, now you equate all this, all the s cube coefficient, the s square coefficient with this, and you will find your value of alpha and k. Okay, from here also you can do, okay, whichever is suitable to you. So this was one question. Another question, I don't have the proper data for this one. A transfer function question came up from the state space equation. Now I don't know if this matrix is correct or not. I'll just show you the method, rest is up to you. So what I recall is that you have been given like this state space representation, and you have been given 4 options. Okay, 4 options you are given, and you had to check, I don't know if it was MSQ or not. You have to check whether which of them had the same transfer function as this state space representation, which of the out of those 4, which of them has the same transfer function. Okay, I'll just find the transfer function here, and then what you have to do is, again you have to do the same computation here also. Yes, that this question was lengthy, so you don't need to attempt it first. You just need to mark for review, and then you need to move on to the next question, which were not lengthy, and then come back to this, because this was doable. This was doable question because this simple formula, you know. What is the transfer function? What is the transfer function formula? Transfer function formula is SI C into SI minus A inverse B plus D. Don't forget the D. Okay, D is important, but maximum 99% of the cases D is equals to 0 here. Just wait 1 second. Let me check if everything is recording. Yeah, everything is recording. Good. Yeah, everything is recording. Fine. So maximum cases D is 0, as I was saying. Now what you do is, you have to find this transfer function. So generally you will get a 2 cross 2 matrix. What I will recommend you is, you don't need to compute this inverse at the starting itself. What I will recommend is, do this. Now you assume this will be 2 cross 2 matrix. Okay, you assume this as ABCD. Okay, you assume this as ABCD. So this will make you more cleaner, okay, and more efficient. And then you do the other calculations. So here we have C and B. Let's do this first. So what is C? C is minus 2 minus 5. I don't know if these are exact numbers or not. It may so happen that the numbers may change. Okay, so you do it accordingly. Now what is this? This is 0 1. B 0 1. Now what you do? You try to compute this first. Okay, because here I have a 0. So it is possible that terms can be gone. Terms can be gone. So yeah. So what I will do is, this will be 2 minus 5, and this is A times 0, B times 1, B, C times 0, D times 1. So simply this is like this column is coming over here. Okay, so BD. Now what is the final result? This is minus 2B minus 5D. Now obviously we'll get a only one term, because it is a CISO system, single input single output system. I have a single output. Y is only 1 cross 1. It is not written, but it is 1 cross 1. And here, sorry, this will be U. This is also a single element only, 1 cross 1. Okay, so sorry, yeah, 2 cross, yeah, 1 cross 1. Okay, so yeah, this is the thing. So that is why we will get a only single term only, transfer function. If it was a multiple input multiple output system, then transfer function matrix, we would have got a transfer function matrix, not a simple element. Okay, now let's calculate. Now what we have to do, we have to calculate this SI minus A inverse. So this SI minus A inverse I wrote as ABCD. Okay, so yeah, let's compute this. So what is SI minus A inverse? SI minus A inverse. So this is S, now minus 1. So this is then plus 2, I think. Yeah, plus 2 plus 3. Okay. So yeah, this is S minus 1 and 2 plus 3. Now we have to compute the inverse of this. So the determinant will come here first, which is simply this plus minus into 2 into this. So this is S into S plus 3 plus 2. Okay. Then what you have to do? Then obviously there is a shortcut. Okay, what is shortcut? For two custom matrix, simply you swap these two, okay, and change the sign of these two. So this will become S plus 3, this will become S, this will become plus 1, and this will become minus 2. For 2 cos 2, this is the shortcut for finding the inverse. Now this is the inverse. Now what you do? You simply what elements you need? You get this with A B C D, A B C D. Okay, here we have B is 1 and D is S. This is S. Don't confuse this with 5 actually. This is S. Okay, so yeah, D is B is plus 1. So here what was the transfer function? It is minus 2B. So my T of S will be minus 2 plus, also don't forget that I have this one in front of as well. This is common term with everything. So I will write this in the denominator because this is common. S into S plus 3 plus 2. Now here what I have, this minus 2 and D, what is D? D is S, which is minus 5D. So this will be minus 5S. Okay, my transfer function will be something like this. I don't know if this is transfer function because this is like a non-minimum phase system. So maybe it may be transfer function, it may not be transfer function. We'll have to see. Okay, so okay, because both of the coefficients are negative here. So yeah, this is the answer for this question. Then you have to again check for the other 4 options and check through the transfer function. Like you could have done a shortcut also. I don't tell you to remember the shortcut. Is that like you could have gone through here, right? So what was this? This is 5s. So you started with this like minus 5 minus 2. This I like taught you in class. Minus 5 minus 2 minus 5s. Then minus 2 s to the power 0. Then this will be the bottom. Like if 1 is like this, right? If your format is like this, 0 1, then minus 2 minus 3, then you can start again like this. It will go like this. So if I write this correctly, this will be minus 5s minus 2 3s plus 2. Now this will change its sign in this direction. Okay, change its sign in this direction. Okay, so like this is a shortcut, but I don't recommend remembering it because you do already remember so many things in the exam hall. You will forget this, and it may so happen you will make more mistake here, and that will cost you the whole marks. Okay, it's better to go with the basics. It may take some time, but at least you will not make the mistake. Okay, so yeah, this is the transfer function for this question, and this is the these were the questions that I found. You can check out the other 2 videos that I have uploaded for control. Those are very good questions, and like if you are preparing again, right, so do watch that video. That will clear your view of your concepts. Thank you for watching, and I will see you in the next video.